This lesson is on factoring polynomials, and it's actually quite a long lesson, so I've split it up into two parts. If you see the specific question you're looking for below, you can directly navigate to one of these examples using the app referenced in the video caption. You can use my app to quickly navigate all of my Math 10 lessons and examples. So the first two examples here are just basic binomials and trinomials where you will factor out a greatest common factor. Example 3 goes over using the distributive property to multiply and simplify the multiplication of two binomials. Examples 4 and 5 are factoring trinomials where a is equal to 1. And examples 6 and 7 are factoring trinomials where a is greater than 1. A is the term in front of the x squared term here, so it's a 2 here, and it will become a 3 here once we factor out the greatest common factor of 2 from that trinomial. If you have no idea what I'm talking about when I'm talking about a, especially for examples 6 and 7, I highly recommend watching the entirety of this lesson. Especially, or if you want to skip the first parts here and you know those, then kind of start before examples 4 and 5. What is a polynomial? A polynomial has two or more terms with at least one variable involved. There are some examples below. You'll see in all of these examples there is at least one variable in there and there are at least two terms. The first one there is a binomial. It has two terms. The second one is a trinomial. And the third one has four terms there. Remember, algebra is using letters in expressions or equations to represent numbers that we do not know yet or that we want to vary, hence the name variable for these letters. So it is important to understand that even though there are letters here, don't let that scare you. They're just numbers you don't know yet, so you can treat them exactly like they are numbers. Anything you can do with a number, you can do with a letter as well. Just like whole numbers can be written as a product of factors, so too can polynomials be written as a product of factors. For example, 4 times 3 are two factors of 12 over here. And over here I've introduced a variable, but 4 and 4a plus 1, those are two factors of the expression 16a plus 4. So bear with me a bit and I'll go into this in a bit more detail. It's pretty important to understand this kind of stuff because otherwise you'll constantly be questioning, well, what the heck is going on here with these variables and factoring variables and whatever. Again, I always like to relate back to the basics of if they're just numbers. Here I'm just showing that when you multiply this out, it's using the distributive property. 4 times 4a is 16a and 4 times 1 is 4. We'll do that in a bit more detail later. So say a is just 1. I'm plugging in 1 in for a. It's important to always use brackets wherever you're doing a substitution here for a variable, then you are much less likely to make a mistake. So I'm just simplifying here now. And so you get 4 times 5 is 20. So I did this because I want to show that 4 and 5 are your factors of 20. And what did we start with before we plugged in the a? We started with 4 times 4a plus 1. So 4 is still a 4, but 4a plus 1 became a 5. So 4a plus 1 and 4, just like 5 and 4, are factors of this. And then 5 and 4 are factors of the 20. So again, these here that are circled are they just become a whole number once you put an a in there. So they look pretty complicated right now, but as soon as you put in a value for a, it's pretty straightforward that they just become a 5 and a 20, say. So again, 4 and 3 are factors of 12, and factors of the expression 16a plus 4 are the 4 and the 4a plus 1. Let's look at how to factor a binomial. A binomial is a polynomial with two terms. Bi signifies two, like a bicycle has two wheels. An example question is, factor the expression 8x plus 4. So determine the greatest common factor between all the terms. Deal with the numbers first and then the variables. So just looking at the numbers, 8 and 4, the greatest common factor is 4. If you don't know that, please do my lesson on factors and multiples of whole numbers. Now looking at only the letters, the 4 term doesn't have an x with it, so the letter term is not part of the greatest common factor. We will look at examples where it is. So the greatest common factor here is just a 4. Let's remember that. Now, we say that we factor out a 4 from both of the original terms. So this is very important to get here now. When you factor something out, you write we wrote our original expression, then we say it's equal to, and we wrote what our greatest common factor is, and then we write a starting bracket. Now, we want to make the right-hand side equal to the left-hand side. This is an equation. You always need the right-hand side equal to the left-hand side, or it is not an equation. So, we ask ourselves now, what do we multiply 4 by to get back to an 8x? Well, we multiply it by a 2x. So good. Now we've covered, 4 times 2x is our 8x. Those are equal. And we still need to get a 4 now, back to a 4 when we add a number here. So what do we multiply this 4 by to get to a 4? Well, there's only one thing that'll do that, and that's a plus 1. The right-hand side of this equation, now we say, is fully factored. The fully factored form of the left-hand side. It is very easy to check if you have factored an expression correctly. Using the distributive property, you can just multiply back out your factored form and see if you get what you started with. So 4 times 2x plus 1, multiplying the first things there, 4 times 2x is 8x. Multiplying the last, you get the plus 4. And you better get the same thing, because that's basically what we use to figure out what we put in the bracketed part here. Example 1. Factor 7x squared plus 21x. Step 1 is always, what is the greatest common factor, GCF? Looking at only the numbers first, the 7 and the 21, the GCF is a 7. Looking at only the x's next, the GCF between x squared and x is x. So x divides into x 1 time. X goes into x squared 2 times. X squared does not go evenly into only one x. This would be like saying 4 goes into 2. So the complete GCF between the terms 7x squared and 21x is 7x. So you combine the number and the variable terms once you figured them out separately. So our 7 and our x forms our total GCF. Now we simply factor out that 7x using the method in the previous slide. So write your GCF, well, your original expression first, then equal to your GCF. Start your bracket. Now, what multiplied by 7x gets us back to this 7x squared? Well, just an x. And what multiplied by 7x gets us to 21x? Well, that'll be a plus 3. And then end our bracket. And you can multiply this factored form back out to check that we factored correctly. 7x times x is 7x squared, 7x times 3 is 21x. So, and again, that's what we basically did to figure out what we put in the brackets, so you better get the same thing in the end. Example 2, factor 8x cubed plus 4x squared plus 6x. This is now a trinomial, 3 terms instead of a binomial, but the steps for factoring are exactly the same as for a binomial. Step 1, always, what is the greatest common factor, the GCF? Looking at only the numbers first, the GCF between 8, 4, and 6 is a 2. Looking at only the x's next, the GCF between x cubed, x squared, and x is x. You'll notice that it's basically the smallest degree of variable. So the complete GCF between the terms 8x cubed and 4x squared and 6x is 2x. our 2 that we figured out and our x that we figured out, we now combine them. Now we factor out that 2x from all terms. So we write our original expression equal to our GCF, start our bracket. What multiplied by 2x gets us back to an 8x cubed, a 4x squared. What multiplied by 2x gets us to 4x squared, a 2x. So when we figure this out, you can basically deal with the numbers and variables separately in your head. So it's like, okay, what times 2 gets us back to the 4? Well, a 2. What times x gets us back to an x squared? Well, just an x. And then what times 2x gets us back to a 6x? Well, the x is already covered. And then the number you need to multiply by a 3. Close your bracket and you're done factoring that expression. Again, as always, you can multiply back out your factored form to see if you factored correctly. Multiplying two binomials is done using the distributive property. Basically, you multiply every term by every other term. Let's look at an example. Multiply or expand and simplify the below. Expand and simplify is another way they can ask the question. So we have x minus 1 times x plus 3. You're going to multiply the first terms to get x squared. X times x is x squared. The first and last to get x times 3 is 3x. And then the inside terms, negative 1 times x is negative x. And finally the last terms, negative 1 times 3 is negative 3. The simplify instruction up here is to collect, that is, add or subtract the like terms, the similar terms. So in our case, just the x's are like terms, 3x and minus 1x. And this process over here of multiplying out or expanding is called foiling, as we multiply the first, outside, inside, and last terms, F-O-I-L. So the first terms, the outside terms, the inside terms, and the last terms. So it's just a little memory tool to help you memorize that you need to multiply everything by everything else. And then you're kind of doing it in an ordered manner every time. First, outside, inside, last. So collecting the like terms, you just have a 3x minus 1x. The minus 3 and the x squared stayed the same. So 3x minus 1x is 2x. And then you were complete on that question. Example 3. Multiply and simplify x plus 4 times 3x minus 2. So using the distributive property, multiplying the first terms, x times 3x is 3x squared. X times minus 2 is minus 2x. 4 times 3x is 12x. And finally, 4 times minus 2 is negative 8. Now we collect like terms, and we just have the minus 2x plus 12x equaling to 10x there. Factoring a trinomial. In the previous examples, we multiplied out or expanded two binomials being multiplied by each other, and this formed a trinomial. Note that the two binomials are actually factors of the trinomial. X plus 4 and 3x minus 2, those are both factors of that trinomial. Remember, x plus 4 is just a number once we put in a value for x. The 3x minus 2 is just a number once we put in a value for x. And the same thing for the right-hand side. So just to kind of drive home this point, let's say that x is 2. Note what I put in brackets there. So we're plugging in a 2 on the left-hand side and on the right-hand side, and we get 6 times 4 is 24. So again, I've just showed that 6 is like our x plus 4 here, 4 is like our 3x minus 2, and 24 is what this trinomial simplified down to. So just like 6 and 4 are factors of 24, this and this are factors of this expression. So, again, note the similarities between those two equations. So we've learned how to multiply two binomials to get to a trinomial, those two binomials to get to this trinomial, but what if we need to go the other direction by actually factoring the trinomial and rewriting it as two binomials? That trinomial equals what? Two binomials. If we didn't already know that the above equals x plus 4 times 3x minus 2, it may be quite difficult to rewrite 3x squared plus 10x minus 8 as the product of two binomials. For this reason, we will now look at a method that requires memorizing a few steps in order to accomplish the task at hand. So factoring a trinomial of form x squared plus bx plus c, where a equals to 1, trinomials are of the form ax squared plus bx plus c, where a, b, and c are integers. We will first look at factoring a trinomial where a is 1. So in front of our x squared term here, there's just a 1. A is equal to 1. We don't need to write it. Always make sure the trinomial is written in order of descending degrees. So x squared, x to the 1, and then our number term. If you had x to the 5, x to the 4, you would have the x fifth term first, x to the fourth term next, then the x third term, then the x squared, etc. There's not too many ways teachers can be tricky on asking questions like these, but one is by just giving say this trinomial as 8x plus 15 plus x squared, and then you'll look at it and be like, well, I have no idea how to factor that. But then you'll say to yourself, wait a second, Carl the tutor told me I just need to rearrange this into descending orders of degrees. I'll just put the x squared term at the start, then the x term, then the numbers, and then you'll say to yourself, now I know how to factor this. So please remember that. That's one of the little tricky things they can do to try to trip you up on the test question. So again, first step is always check for a GCF. In this case, there is none between the three terms, so we can't factor that out first. This is where we need to memorize the below step. What two numbers multiply to be the third term, 15, and also add to be the middle term? So this is one of the main things you need to memorize for factoring these kind of questions. The two numbers that multiply to 15 and add to 8, the middle term. Multiply to the last, add to the middle. Remember that. So in our case, those two numbers are 5 and 3. 5 multiplied by 3 is 15. 5 plus 3 is 8. So let's remember those two numbers. So we can factor these quite quickly. Write down two brackets to start forming your two binomials. The first step now is writing the square root of the first term in the first two places of these binomials. So the square root of x squared is x. So that's pretty straightforward. And then those two terms that you memorized that multiply to the last and add to the middle, you put in the second places of the binomial. So plus 5 plus 3 there. And we are actually completely done factoring now this kind of question. FOIL out, multiply, expand, the two binomials on the right-hand side, collect like terms, and you'll see that you get back to the trinomial. Example 4. Factor x squared plus 5x minus 24. So step 1 is always checking, is there a GCF? There is not. So we need to recognize that a term here, the term in front of the x squared, is just a 1. It's not shown. So we can directly write our two binomials here, leave enough room in here for two terms in each. So the square root of the first term here is what we write as the first term in each of these binomials. And then what two numbers multiply to negative 24 and add to 5? Those two numbers will be negative 8 and plus 3. Negative 8 times minus 3 is negative 24, and negative 8 plus 3, plus 8 and minus 3 are the two numbers. So see, as you're checking those numbers in your head, you'll go along and say, okay, plus 8 times minus 3 is this, and plus 8 minus 3 is going to be that. And if it didn't work out, then you'll know you did something wrong. So you can notice there, I only just had to switch the negative and plus sign. So plus 8 and minus 3 are our two numbers. And we now have the factored form of the trinomial. So we'll write that as our final answer. Example 5, factor x squared minus 13x plus 36. So again, always check, is there a GCF? There is none here. But a is equal to 1, so we're going to try to factor this by going to two binomials. Write down the square root of the x squared in the first place of each of these binomials. And now, what are the two numbers that multiply to 36 and add to negative 13? Well, it can't be two positive numbers because we need to add them to negative 13. It can't be a positive and a negative number because a positive number times a negative number will be a negative number here, and we have a positive 36. So they both have to be negative numbers. So what two negative numbers multiply to 36 and add to negative 13? Well, those two numbers are negative 9 and negative 4. Minus 9 times minus 4 is positive 36, and minus 9 minus 4 is minus 13. So those are our two numbers, and we now have the factored form. So I will end part 1 of this lesson here, and part 2 will be a separate video. But again, you can use my app to quickly navigate between all of my videos and all of my examples. So see you in part 2.